All right, question 2, materials and structures. Now, the question 2 starts section B. So we're going to go over question 2 starting from 2.1 all the way up to 2.6 for 35 marks. Okay, so for the first question, that is 2.1.1.1, they want us to indicate the alloy metal, not just any metal, an alloy metal that is specifically used to manufacture the following products, and give 2 reasons why the material is used. Now, for the first question, what material is used for making milk tanks? Okay, so for milk tanks, it's gonna be stainless steel. Stainless steel is used. Now for the reasons, now there's several reasons, but since they are requesting or asking us to provide 2 reasons as to why the metal is used, I'm going to provide 2 reasons. Now, the first reason is that it's corrosion resistant. It is corrosion resistant. So, you know, since the metal is going to be used for milk, for a milk tank, milk contains acid called lactic acid, and is often cleaned with chemical sterilizers, right? So using stainless steel is going to be a better option, because the chromium contained actually forms a passive oxide layer that prevents rust and chemical attacks that comes from the chemical sterilizers. Okay, so the reason why we are going or opting for stainless steel is because of its corrosion resistant. Now, the second reason would be it's because of stainless steel is okay, let me erase, or let me just say it is weldable. It is weldable. Is this even a word, Mar? Weldable. Yeah, it can be welded. Or let me just say it can be, yeah, let's say it can be welded. Well, okay, let me explain what I mean by this. Stainless steel, it is weldable, or it can be welded well, meaning that the welded parts of the stainless steel, it ensures that the seams that can be it ensures that the seams can be sealed perfectly during the manufacturing and welding, maintaining a contaminant free environment. So let's say stainless steel, when welded, it makes sure that bacteria or contaminants coming from the outside environment don't have any sort of like holes or cracks that it can seep through in welded parts of the stainless steel connections for the milk tanks, right? So here's your 3 marks for providing the answer and the 2 reasons. Next question, 2.1.2, fittings for hot water copper pipes. Okay, the best option for this, it's normally brass. Fittings for hot water copper pipes. Okay, so the fittings are going to be brass. 2 reasons is it's because of their strength. And their machinability. 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 Well, because brass can maintain its strength at very high temperatures, since hot water will be going through the copper pipes. So at the joints you're gonna have, or you're gonna find brass. So since they have higher strength at high temperatures, they can hold their own. Machinability part now, it's because of its easily machined into precise threads and fittings. So it is easier for the manufacturing process to become, a bit easier for the bending, creating threads and fittings, and ensuring that leak-free connections are established. Okay, so that is why brass is a better option. Now for the 2.1.3, we have hammering tools that can be used in explosive atmospheres. I think bronze. Bronze is a better option. So bronze, and the two reasons, it's because of its non-sparking properties. Okay, non-sparking properties, and it is corrosion resistant. Corrosion resistant. I think this is a somewhat a common reason that you can provide, especially involving questions that speak about, alloys and stuff. Now, the bronze durability under heavy use while resisting rust in humid and corrosive farm environments. That is why we are saying it is corrosion resistant. Okay, so in the non-sparking properties, they provide us with preventing instances of ignition of flammable gases. If this thing was sparkable, if it was sparkable, it could actually cause explosions if it was next to flammable gases, vapors, or dust found in grains, silos, or fuel storage environments. So bronze is a proper option, or best option, because it is non-sparkable. So if you had such materials around, it was going to cause explosions and fires. So due to its non-sparking properties, it is a good option. So bronze is our option for 2.1.3. Now for 2.2, name two hot working processes that can be used to change the structural properties of brass. Okay, this is textbook stuff. Okay, first of all, we have annealing, and we also have stress relieving. Okay, so heating brass above its recrystallization temperature, and then slowly cooling it to soften it. It does relieve the internal stresses and improve ductility for further shaping. Okay, so that is one hot working processes for bronze. Okay, so heating it to a lower temperature to reduce residual stresses from previous cold working, or preventing stuff like cracking or distortion during use. It's for stress relieving. So that is why, um, there are several options that I can list out here, but this is what I can think of right now. 2.3, concrete and fiberglass drinking troughs are used to provide water to farm animals. For the first one, 2.3.1, they want us to give 2 reasons why farmers would prefer fiberglass troughs instead of concrete troughs for cattle. Okay, first of all, fiberglass. Fiberglass, when compared to concrete, it is lightweight, number one, right? So, in a farm, I think it is preferable to avoid using machinery, um, to avoid using machinery and use labor instead. Why? First of all, it saves costs. Okay, it saves costs. Since fiberglass is lightweight when compared to concrete, I would say I'll provide the first reason by saying fiberglass is because of it is lightweight. It is lightweight. So because it can be easily moved around without using heavy machinery, right? So fiberglass, it is lightweight, and it is also durable and durable and rust, not dust, rust resistant. Rust resistant. And unlike concrete, fiberglass does not crack or freeze. It does not, it does not crack in freeze tow cycles, and it also does not corrode or and another thing, due to its smooth surface, it inhibits algae and bacterial growth inside, right? So that is why it is an option over concrete. So it is durable and rust resistant. Fiberglass is also lightweight. For the 2.3.2, describe the resin that is used to manufacture fiberglass products. What is it called? What is it called? It's the polyester resin. So now they want us to describe. So they want us to describe the resin. Okay, so let me start off by saying, let me use black, not blue. Let me start off by saying this. Number one, it is a low viscosity fluid that when mixed with a hardening agent or a catalyst, it undergoes polymerization to form a rigid and a durable solid that bonds with, okay, forgive the flashing of my writing. I don't know, maybe the PDF reader is unstable or what, I don't know. Okay, bonds with glass fibers. glass fibers. Glass fibers. Now it is ideal because of its cost effective and cures easy at room temperature, and is resistant to water, chemicals, and UV degradation, making it suitable for outdoor farming equipment. So that is the reason, the resin description. Now for the 2.3.3, name two methods that can be used to join fiberglass parts. There's two. Let's see. So we have the following options. Mechanical fastening. Mechanical fastening. Mechanical fastening. That involves things like pop rivets. Hang on a second. Pop rivets. Another option would be, bolts and nuts. Bolts and nuts. All right. So such fastening processes, it provides a strong and reversible joints that can often be used with sealant to prevent water ingress. So this is one option, a mechanical fastening process. We also have laminated bonding as well. Laminated bonding. So this involves a process where we overlap the fiberglass matting with fresh resin. Then it creates sort of like a seamless monolithic joint that is often stronger than the original material. So these are the two methods that can be used to join fiberglass parts. 2.4. Let me try writing this side. Maybe it won't flash as much. Interesting. Okay, so give 5 reasons why Vesconite is the best material for the manufacturing of bushes. Okay, let's change the color of our pen. Perhaps blue this time. All right, so we have point number 1. Point number 1 is self-lubricating. Self-lubricating. Okay, so it contains embedded lubricants. For example, something like graphite, reducing friction without external, greasing. This is ideal in dusty environments where grease attracts grit. Am I saying this right? Yeah. Grease attracts grit. Point number 2, we have low water absorption. Low water absorption. Low water absorption. So unlike nylon, which in a case where water is ingressed, it swells, right? So Vesconite maintains dimensional stability in wet conditions. This does prevent seizure on shafts. Yeah, shafts. 3, we have another reason, which is it has excellent, I can excellent, double L, excellent wear resistance. Excellent wear resistance. So when reinforced with fibers and feelers to withstand abrasive, farm contaminants like soil and sand. So that is why it is an excellent wear. It is it has an excellent wear resistance. So in a case where there's soil and sand involved, it is good in withstanding such wear and tear. Wear and tear. So for the fourth one, we have chemical inertness. Chemical inertness. So this simply means that it doesn't easily react with other chemicals. So it resists. It is easier for it to resist degradation from fertilizers, other stuff like fuels and animal waste, which contains chemicals which can corrode the metal or degrade other polymers involved. So it is not so much of a material that can react with other chemicals that easily. So for the fifth point, it has high load capacity and thermal stability. High load capacity and thermal resistance and thermal stability, not resistance, stability. All right, so that is our last point. So I think I'll have to erase some parts here, perhaps this one, this part. Okay, now I just decided to erase everything. Let's see if the fleshiness of the paper won't start again. Alright, now we are at 2.5, not the last question. We still have 2.6, which is the last question for question 2. So 2.5, they want us to describe how an adhesive should be applied to a surface to ensure sufficient cohesion. Alright, so an adhesive, it's something like, that can stick, right? Two materials together, should be applied to a surface to ensure sufficient cohesion, sufficient or enough bonding between the two joining materials. So for 2.5, how many marks? 4 marks. Yeah, you know what? Let's start with this one. Let me use another color. Number 1. Okay, I don't need to number this one. Okay, so first of all, we need to start off by preparing the surface. Okay, we can do a surface preparation. This involves cleaning the surface, removing oils and oxidation like rust and all that stuff. The abrasion will increase the surface area for the mechanical bonding. So we start off by doing what? Doing a surface preparation. Now, the next step would be priming the porous surfaces. Priming the porous surfaces. Priming the porous surfaces. Okay, I'm writing in bullet point forms because where I'm actually writing, man, it keeps on flashing, and I don't want that. And it's also a bit of a challenge when I keep on writing here. So I'm just gonna, hit the key points, hit the key phrases, right? Then you can just fill in the rest on your own. Okay, but I'll try to provide some reasons as to try and connect all the points that I'm listing out here. So we are priming the surface now. This actually prevents the adhesive absorption, ensuring that full coverage at the bond line. Okay, at the bond line. So we are trying by all means that the adhesive that is going to be used for the adhesive that is going to be used for the for the cohesion is not absorbed by the material. So we're going to start off by priming the porous surfaces. So we're going to try to, prep the surface by filling in those small holes on the surface, so that once we start applying the adhesive, none of it is actually absorbed, or all of it is absorbed. Most of it is left on the surface so that it provides enough contact between the combining materials. Okay, then from there we're gonna have a thin and even application of the adhesive. A thin and even application of the adhesive. Thick adhesive layers, they tend to cure unevenly, right? So we are trying to create a situation where the adhesive, when applied, it actually provides a sort of like an even layer of adhesive, and it is also thin. So if this is not achieved, this will create weak points and reducing shear strength of the cohesion between the two materials. All right, so this is another phrase that I think is key in the discussion or in the description of this question. All right, so we also have bonding both the surfaces. Now it's time for bonding both the surfaces. Bonding both the surfaces. Okay, so this will ensure that complete interfacial contact is established, right? Now this maximizes the chemical adhesion of the adhesive. All right, so I think another point that I can list here would be the curing under pressure. Now curing under pressure. Now that the two surfaces have been bonded together, now it's time to allow for the adhesive to start curing and securing the two materials once bonded. So this will maintain the intimate contact during the curing process. This will eventually prevent air pockets and ensuring a continuous bond. So after bonding the two surfaces, they should be maintained in that position so that no air seeps in and compromise the bond between the two bonded surfaces. Now let's go to 2.6. Let me switch back to black. Now an earth return system is shown in the diagram below is needed for the electric fence to function effectively. We have an energizer here, a live connection, live fencing. This is also grounded to the earth. Alright, now for 2.6.1 they want us to briefly discuss the procedure that must be followed when testing the earth system of an electric fence. Okay, 2.6.1 discuss the procedure that must be followed when testing the earth system of an electric fence. Okay, now here's the important part. Here's an important point. Here's an important point. Number one, we need to short the live line to the ground. Short the lifeline to the ground, as they did here, to the ground, right? This will create a control circuit to test the ET performance. This is crucial. This is very, 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 very important. Very important. Right? We are discussing, so you shouldn't list out in bullet point form. Just try to write in paragraph form. Okay? You know my situation as I mentioned above, right? So I'm gonna hold the discussion like I did with 2.5. So for 2.6.1, I'm just gonna highlight the important points. Just fill in the gaps. Just use your own English to finish up here. All right. So next would be to energize and measure the voltage from after grounding. That is to energize and measure voltage Now this would involve using a voltmeter between the ground and the ET spikes, right? A voltage reading that is greater than 200 volts would indicate high resistance, meaning that the ET system cannot safely dissipate charge, leading to poor fence performance and shock risks. Something like that. Yeah, something like that. But we start off by grinding, then we energize and measure the voltage, right? And measure the voltage. That is the procedure that is required to have an effective testing of the ET system. Okay, now for 2.6.2, give two examples where electric fences are used on a farm. Right, so I think that should be obvious, right? That should be obvious, man. Predator and perimeter security of the farm. Perimeter security of the farm and rotational grazing management. Rotational grazing management. I think these are 2 points that I can think of. All right, now for the last question, we have a 2.6.3. 2.6.3. Name 3 alternative energy sources that can be used to supply energy to an electrical fence. Okay, another textbook example. I mean a textbook question here, right? So there's quite a few options here, but they are asking for 3. I'm thinking solar. I'm thinking wind energy, right? I'm also thinking okay, I'm saying it's easy, but now I'm stuck. I can only think of 2. What about hydro? I think hydro should work. Water, if there's a flowing river stream nearby, right? So the flowing water that is available can be used in conjunction with small turbines to provide consistent power, especially in mountainous farms and river or farms that are next to the river. This is appropriate for such cases. So another option would be water. Another turbine that is operated by wind can also be used. Solar requires the sun. So these are the 3 options that I can think of right now. So this is our 35 marks for question 2. Now for section B, the next part of our section B, that is question 3 involving energy.